Leetcode 268, missing number. It's an easy problem, and it even might be very easy if you know some high school math formulas, especially the ones related to arithmetic sequence. But if you are out of high school for some time, like myself, you would probably like some other approach, maybe something more programming related. So we will discuss at least two approaches. Maybe I will try to give you some ideas for more than two, but for sure at least two we'll try to code and compare which one is faster and so on. But there are many different ways in which you can tackle this problem. So here is the description. Given an array nums, that's our input array with numbers. So collection of elements, linear collection, and the elements are just numbers like 5, 6, maybe then 4. They don't have to be ordered in any fashion. But there are some constraints. So there is n of them containing n distinct, that's the first constraint, numbers. So there are no repetitions in the range from 0 to n, meaning that we already know what's the minimum and what's the maximum in every input. Because the minimum is always 0, but the maximum is equal to the number of elements. Just the number of elements, not n plus 1, n minus 1, just n. Return the only number in the range that is missing from the array. So there will be one number every time from this range between 0 and number of elements, which is missing, and we have to find it. Here are the examples: 3, 0, 1, that's the first input array, and what kind of number could be missing here? Of course, 2, and we can already see it, that the missing number from the range between 0 and 3 is 2. And here they added some additional explanation. N equals 3, since there are 3 numbers, so all the numbers are in range between 0 and 3. 2 is the missing number in the range since it does not appear in nums. Well, that's it. Here is the second example. We have 0 and 1, which are already ordered, but what could be missing here? Well, we know what could be missing since the number of elements is equal to 2, and our range in this case is 0 to 2, meaning that 2 is not meaning the 2 is the missing number since it does not appear here. Yeah, so the max and min might not appear in the input, but we will always know for sure what are those. Yeah, so we can always get the maximum just by counting the number of elements. And here is the third example: many numbers, as they say here, 9 of them, and the one that is missing is 8. Since it's between 0 and 9, and if you would just try to find each one, 0, okay, 0 is here, 1 is here, 2 is here, 3 is here, and so on, up until 8. 8 is not here, so that's our missing number, and that's it. So now, let's try to think about some ways in which we can solve that problem. So first is using arithmetic sequence. And I tried to Google it before, since already forgot some of the ways. And here is a formula for the sum of n terms. And in our case, the first term would be 1, and the nth term would be n. Yeah, so this formula gets a bit, it can be a bit simplified to the following. Let's make it bigger. Now, n times n plus 1. By the way, if anyone knows how to use LaTeX here, let me know. This would save me some time, but for now I am drawing the fractions by my bare hands. And that's more or less it. We can sum the numbers which are here. So do compute the sum of all elements nums, or just compute the sum of nums like this. Should be clear enough. Then compute the sum using arithmetic sequence formula or just like this. And the missing number is x equals to Sn minus, let's call it sum. That's it. If you know that approach and if you know that such formula exists, that's more or less it. The second approach that we can use is using bitwise operators, or not operators, operations. Operations. Strong. Let's do it like this. And especially XOR. But maybe first let's try to plug it in. So here we have 3. So in this case, we have 3 plus 0 plus 1. So the first one equals to 4. Yeah, and the Sn is equals 3 times 3 plus 1, which is 4 times 3, which is 12 over 2, which is 6. Yeah. And that's 6 minus 4 equals. We verified that the approach works. Let's verify this. Here is our answer. And XOR or XOR is bitwise operation, or it can also be a logic gate, and basically it has couple properties that we can use, and that's something that's more useful in programming than knowing that kind of formulas. So let's write down some of the properties of XOR, and basically A XOR A, for any number A, it will always be equal to 0. Yeah, so 1 XOR 1 is equal to 0, 5 XOR 5 is equal to 0, and so on. But A XOR 0 is equal to A, which is another important property. The next two are commutative and associative. And basically that means that A, for any number A, if we do some kind of operation, could be XOR, let's stick to XOR, yeah, but in general, any kind of operation, if it's commutative, then if you do it between two numbers, it doesn't matter in which way you apply it, yeah? So A XOR B is also equal to B XOR A. And for associative, we have even something more interesting. If we add another C, and it means basically that we can apply parentheses in any manner we want, and doesn't matter if we first compute this, then this, or in the other way around, which will be important for our solution. All right, so that's basically bitwise XOR. And now the whole idea is to, in a loop, get all the numbers. So get every num out of nums. And have some x, which will be equal to sort result of XOR or XOR between num and its index. Yeah, and what we will get here? Let's move it here like this, and we will get first 0 XOR 3, then 1 XOR 0, and then 2 XOR 1. Indices 0 and element 3, index 1, element 0, index 2, element 1. That's it. And that we can initialize x with n. So n is equal to 3, and we can initialize x with n. So basically, we can simply start with this. I hope that you can see where I'm going with that. And everything is also XORed between each other. And what can we do right now? We can group similar elements. Yeah, so for example, there's 3 here and 3 here. And there is 0 here and 0 here. There is 1 here and 1 here. So if we rewrite it, we can have, let's make it black, 0 XOR 0, and then 1 XOR 1, 2 XOR 2, no, sorry, not, 3 XOR 3, and the only left element is 2, and that's our answer. So all of those cancel out, we get 0 out of them, 0, 0, 0, and what we are left with is 2, and that's all. So now we can try implementing both of those approaches and see how it goes. So for the first one, we need to have the end equals to length of nums. Then we need to have sum of nums, which is equal to sum. And we also need this sum of arithmetic sequence, which we said is equal to n plus 1 over 2, divided by 2, and return sum of arithmetic sequence minus sum of our input elements. Let's see if that works. And here I forgot the multiple. Tap it and see how fast we are. Very fast, and that's beats 100%. And the other approach, so that would be option 1, use sequence, and option 2 right now using the export. And we also need n, of course. We need our x to be initialized to n, and then our loop for I and num, enumerate nums. We do x is equal to x or between I and num. And the end return x. Let's try to submit. Yeah, and this one is not that fast, of course, because we are doing some operations in a loop. And here we are simply relying on the formula and doing one difference between them. Yeah, so this single operation here we also have constant operations. The only thing that would be changing here is this sum, but it depends on how it is implemented by Python. And so it might use some more advanced operations inside. Who knows? Or maybe it's just a loop. But here for sure we have a loop, and we have two operations in every loop iteration. That's why it's a bit slower, but it's something that probably you will remember better than relying on the formulas.